So today we're looking at 5.2b. We're going to take the information that we learned in 5.2a and put it all together in a graph of a quadratic function. So this time we're going to learn how to graph a quadratic function in any form, as opposed to just the ones in vertex form where we can see the transformation. So the last piece we need to learn before we graph is how to find the y-intercept. Now finding the y-intercept of a quadratic function is not any different from finding the y-intercept of any other function. Step 1, substitute 0 for x. So everywhere you see an x in your function, now remember this w of x, that's just function notation. What that means is that the name of this particular function is w, and the independent variable in the original function is x. So whenever we're substituting a value into the function, we're saying, now we're going to evaluate our w function at an x value of 0. So we replace all of our x's with 0. And again, another reminder, w of x is function notation for y. So we are solving for y, it's just in function notation, and I keep using that because I want you to get used to it. All right, order of operations, 0 minus 3, we're going to evaluate what's in the parentheses first. 0 plus 5, multiplying them together. So solving for y. And then step 3, always write your intercept as an ordered pair. We started by substituting 0 for x, and we solved and got negative 15 for our y value. All right, so first we're going to look at graphing in standard form. Now the steps that I have in the right-hand column are just for graphing. The steps for up or down, axis of symmetry, vertex, those are all on the notes from yesterday. And the y-intercept steps are on the first slide. So I'm not going to be showing any of the steps until we get down to the graphing part. All right, does it open up or down? We look at the coefficient of our x squared. If the coefficient of x squared is positive, it opens up. If it's negative, it opens down. What's the axis of symmetry for the standard form? It's x equals negative b over 2a. So in our equation, b is negative 6. So negative 6 is positive 6. A is negative 1. 6 divided by negative 2 is negative 3. So the equation for the axis of symmetry is x equals negative 3. That is also the x-coordinate of the vertex. So to find the y-coordinate of the vertex, we substitute the x value into our function. Now remember, in this case, our coefficient of x squared is negative. That's where this negative comes from. And then our x value is negative 3. So using order of operations to evaluate this, we first square our negative 3, which is 9, and then multiply it by a negative 1, which is what the negative coefficient does. And then the next part, I look at that as a negative 6 times negative 3, which is positive 18, which gives us 10. So that is the y-coordinate of the vertex. We're going to write that as an ordered pair. Our x-coordinate is negative 3 from part B. Y-coordinate is 10. Y-intercept I didn't leave much room for because when we substitute 0 into our function for x, this goes to 0, this goes to 0, our y-intercept is 1. And domain and range. Domain for any quadratic function is all real numbers. Range, because the graph opens down, y is less than or equal to the y-coordinate of the vertex. So make sure you grab the y-coordinate of the vertex, not the y-intercept. And then we're going to graph. All right, so here are our steps to graph. Step 1, plot the ordered pairs that you have. We have the vertex and the y-intercept. So I'm going to graph negative 3, 10. There's my vertex. What I know is this is in this case, the highest point of the graph. It's the maximum value because it opens down. And then my y-intercept was 0, 1. All right, sliding back up for the steps. Step 2, use the axis of symmetry to reflect the y-axis, or sorry, the y-intercept. So the axis of symmetry goes through the vertex. It's a vertical line across which the parabola is symmetric. So you may want to use a different color so you don't lose your vertex there. So reflecting our y-intercept across the axis of symmetry, it is 3 units to the right. So I'm going to go 3 units to the left of the axis of symmetry and grab another point. And then you just use those points to make your parabola. So sliding back up, that is step 3. Remember, your parabola should be curved and going through the vertex.